So lesson 69 is on matrices and determinants. Have you heard of matrices before? In geometry, did we do the matrices? There were lessons on matrices and transformation by matrices, and we skipped them because we're doing them this year. I skipped them last year so that we could do them this year. I think matrices are really interesting. I had a class on it in college, like that's all it was on matrices, and I loved it. But, I mean, you may not like it that much. I took 46 hours of math classes out of 120 hours total. So over a third of my classes were math. No, I don't really like math.
You're a science person.
Yeah, totally science person. I'm just trapped in a math teacher's body. Okay, so matrices is the plural of matrix. So singular matrix, plural matrices. Matrix is a rectangular array of numbers or symbols that stand for numbers. So rectangular, it doesn't have to be a square, it just has to make a rectangle. You know what rectangles look like. So the individual entries of a matrix are called the elements and are always arranged regularly in rows and columns. They're very uniform, they're very structured. It's not all jumbled up. When you think about the military and they go marching somewhere, they're going to be very structured in rows and in columns. And our matrices are going to be very, very structured. Do what? Yes, when a band marches in a parade, y'all are in your rows and your columns. And you get yelled at if you get out of them. Matrices have to stay in their rows and their columns. So all rows have to have the same number of elements, the same number of entries, and all columns must have the same number of elements or entries. It's not saying that all the rows and all the columns have the same number. All the rows have to have the same, and then all the columns have to have the same. So all of the rows could have 2 entries, and all the columns could have 100 entries. That'd be a really long matrix that I wouldn't want to have to deal with, but that would work. It is customary, but it's not like required, it's not necessary to use brackets to indicate that an array is a matrix. So usually matrices have brackets, but they don't always. And the brackets that they use look like that. So they don't always have brackets, but usually matrices have brackets. And then the dimensions of a matrix are given by naming the rows and then the columns. So let's think about this. Are rows horizontal or vertical? Rows are horizontal. And then columns are vertical. How can I remember that? Columns on a building, they are vertical. So we always start going horizontal and then vertical. Go with me so far? All right, so these are all examples of matrices. So we're going to practice naming them. Well, how many rows do they have, or does this one have? 3 by 1, because it has one column. 3 by 1. What about this one? How many rows? 2 by 3. This one? Okay, this one. All right, this one. What about 3? What about this one? Okay, what about this one? What about that one? And this one? Okay. Do you see how a couple of the matrices don't have brackets, but the rest of them do? These are all matrices, and they're all different. Any questions so far? Okay. If a matrix has the same number of rows as has columns, the matrix is a square matrix. So let's look back real quick. Which of these would be a square matrix? Would the 3 by 3 be a square matrix? Because it has the same number of rows and columns, and the 1 by 1, and the 2 by 2. Square matrices are special because they can be associated with a real number called the determinant. Only square matrices can have a determinant. So every square matrix has a determinant. If it is not a square matrix, it cannot have a determinant. So determinants are only associated with square matrices. The determinant of a matrix is usually designated by enclosing the matrix with vertical lines. So instead of having little braces, we have vertical lines that enclose it. You see how this one has vertical lines here and here? It's still a matrix, but now we're going to find the determinant because it's straight lines. So our matrix is A, B, C, D. Your determinant is found by saying A times D minus C times B. A times D minus C times B. Always minus. You are going to have to learn that it is A times D minus B times C. So, in case you are worried about remembering it, the book has this lovely picture. And I'll read from the book. Sometimes one forgets which product is positive and which product is negative. As a memory device, we will superimpose the problem on a map of the United States and associate the minus sign with the cold waters of the North Atlantic, and associate the plus sign with the sunshine of the islands of the Caribbean?
Okay.
Because you'd be happy to be down in the Caribbean, and you would be sad to be up there where it's cold. Like if you keep going, like over here, there's water. Do you see how that works? So that's their memory device. So we want to find the determinant. So how are we going to find the determinant for this one? -4 times 7 minus 2 times -3. So what? So what do you get? And that's your answer. Y'all see how that works? Okay. What are we supposed to evaluate on this one? Line. Because it has a vertical line. So what would we do? Alright. Y'all see how this works? Okay, this one is a little bit different. Yes, we have to find x. What is it telling us? The determinant is 18. So how are we going to find x? Okay, what would be our equation? Okay, so 4x plus 16 minus 6 . So what would 4x equal? So what would x equal? Do y'all see how that works? Okay, so 2 would be your answer. Let's look at one more. So what would you do? Okay, now what? Now what? -2? Okay, now what? Will it factor? Does it factor? So what are we going to have to do instead? Okay, so -b plus or minus okay, so I'd have -6 plus or minus, and I have 36 plus 8 over 2. So what is 36 plus 8? So how can I rewrite the square root of 44? Two squares of 11. And do I leave my answer like that? I would say, so that's what x equals. Y'all see how this works? So our matrices, or determinant, the determinant part of matrices, is that really that complicated? So right now we're looking at 2 by 2s. We will eventually look at 3 by 3s, But other than 2x2s and 3x3s, that's all we're doing this year. If you took a class, no, we won't deal with matrices next year. But if you took a class in college dealing with matrices, you'd get to 5x5s and 6x6s and all of that lovely stuff. Well, once you learn the 2x2s, then you can learn a little bit about the 3x3s, and then from there, it's the same concepts. It's just more, takes longer. So, when is your homework due?
Tuesday.
Why Tuesday?
We're not here Monday.
Right, you have a holiday Monday. And what problem set is it? All right.